Hello everyone! Today we're going to talk about the Earth's mechanism, specifically the mantle convection. At the end of the lesson, you are expected to describe the possible causes of plate movement and recognize the process of convection current in the mantle. Before we start, do you still remember the plate tectonic theory?
The theory of Alfred Wegener stating that Earth's lithosphere, the crust and the upper mantle is broken up to several pieces called plates that move slowly. Are you familiar with convection? It is the transfer of heat energy wherein the hot but less dense material rises and the cold but more dense material sinks. There are three types of convection: radiation, conduction, and convection. And a good example of such is boiling of water. This is radiation, conduction, and convection. But don't worry class, we will only use the convection in the entire topic. What is a convection current?
It is a heat transfer process that involves the movement of energy from one place to another, where the hot fluid tends to rise and cold fluid tends to sink. These are due to the difference in densities and the temperature. Convection current happens in the mantle. As you already know, the mantle is hot, but why? It gets its heat from the core, which contains the decay or breakdown of radioactive elements such as potassium, uranium, and thorium.
The magma is hot because of the heat it gets from the outer core. As mentioned earlier, hot fluids tend to rise due to low density, while cold fluids tend to sink due to high density. So, if the magma here is hot, it will rise, and when it gets to the top, it gets cold because it is far from the core. And since cold fluids sink due to high density, it goes back to the bottom. This cycle goes on, which we call the convection current. Aside from mantle convection, there's slab pull and ridge push that move the lithospheric plate. Slab pull is the process where the heavier subducting plate pulls the trailing slab into the subduction zone. The ridge push is the process by which old oceanic crust becomes heavier than the new oceanic crust and sinks because of the weight of the raised ridge, which pushes down the older crust towards the trench at the subduction zone. Now, how does this relate from the previous lessons? As you can see in the picture, this part rotates clockwise and this here rotates counterclockwise. If the magma continues to rotate away from each other, the asthenosphere will tear apart, and if it does, the lithosphere riding it does too. This is why divergent boundary happens, and if you look here, the direction it rotates meet the other rotation. And if it continues to do so, they will collide. Thus, the convergent boundary.
Do you have any questions? If you do, directly notify your teachers. This presentation is presented by PNG Acting Group, School Year 2022 and 2023. Members in alphabetical order: Alinghawa Winch, Karanay Princess Loring, Florina John Paul, Lebrinka Zarina K, Nepaya Maravi.